The universe consists of 68% of dark energy, 27% of dark matter, and remaining 5% of normal matter. In this 5% of matter, there are lots of celestial bodies, each one with different properties. Starting with planets, there are three types of planets. Terrestrial planets. These planets are made up of silicate rocks and metals. Planets like Earth, Mars, Mercury, and Venus come under these terrestrial planets. Gaseous planets. The planets which are made up of gases like hydrogen and helium are called as gaseous planets. Jupiter and Saturn come under these gaseous planets. Many people think these planets have surfaces, but reality is they don't have any surface and it's completely covered with gas. Ice giant planets. These planets are made up of oxygen, sulfur, carbon dioxide, and nitrogen elements. Planets like Uranus, Neptune come under these ice giants. Planets outside our solar system are called as exoplanets, and planets that are unable to inhabit the properties of planets are called as dwarf planets. They lose their ability to become a planet, and there are about 200 dwarf planets in our solar system. But these planets are useless until they have connection with their host star. Planets that lost connection with their host star and live in dark for ages are called as rogue planets. Moons. This is a celestial body which is smaller than planets and affected by gravity pull of planets and making them revolve around themselves. All the planets, moons, and everything in the solar system is controlled by a star. These stars are of three types. Red dwarf stars. They are smaller in size and have lifeline of 73 to 5000 billion years. Orange dwarf star. They are smaller than our Sun and have lifeline of 17 to 73 billion years. Orange dwarf stars are the biggest than red and orange dwarf stars, but their lifeline is less. They have 4 to 17 billion years to burn. Our Sun comes under this yellow dwarf star. But some kinds of stars are 1 to 250 times bigger than our Sun, and these types of stars are called as blue giants. They have lifeline of 3 to 400 million years, but in the case of blue giants, if they are edge of their lifeline, they will become as red giants, supergiants, and hypergiants. Red giant stars. They are 20 to 100 times bigger than our Sun and have a lifeline of 0.1 to 2 billion years. If these stars are out of hydrogen, they will explode and create a planetary nebula. After this explosion, the gas around it forms a white dwarf star. The fact is, even the red dwarf and orange dwarf star will become a white dwarf star when they are out of their hydrogen. White dwarf stars are very small in size, but they are very heavy. Maybe there is no death for these white dwarf stars because their lifeline is like trillion years. After that, they will get dimmed and get converted into black dwarf stars. But unfortunately, we didn't find any evidence that these black dwarf stars are present. Red giants and hypergiant stars. These stars are 1000 to 2000 times bigger than our Sun and have a lifeline of 3 to 100 million years. The deaths of the star cause supernova, and this supernova might be converted into a neutron star or a black hole based on the conditions. If the star is 40 times bigger than our Sun, then its core will collapse into itself and create a black hole. Black holes are the weirdest celestial body in our universe because it has immense gravity, even light can't escape from them. And that is the reason why we can't observe a black hole even with space telescopes. If the star is less than 40 times the size of our Sun, then it will be converted into a neutron star. This neutron star has 1.4 times more mass than our Sun. Due to its magnetic fields of the neutron star, its poles will release an electromagnetic radiation and also revolve around itself at the extreme speed, and they are called as pulsars. Sometimes this neutron star will orbit around a normal star and absorb the complete matter of the star by revolving. This type of pulsars are called as X-ray pulsars. After the explosion of the supernova, there will be a large amount of hydrogen released into space like clouds. These clouds are called nebulas. They are one of the most beautiful things in our universe. The births of new stars will take place inside the gas clouds of nebulas. If a large number of stars are being together in a specific region of space, then they are called as star clusters, and these star clusters are of two types. Globular star clusters. In these clusters, millions of stars will be pulled together by their gravitational power and form a cluster. An open cluster is similar to globular cluster, but they follow some kind of social distancing. But all the stars in our universe are under control of galaxies, and these galaxies have types based on the structure, like elliptical galaxies, spiral galaxies, irregular galaxies, and many more. The core of galaxies contains a supermassive black hole. If that black hole releases rays like this and also pointing towards our Earth or solar system, then it is called as a blazar. Or if it is pointing anywhere else in the universe, then it is called as radio galaxies. If that black hole eats all the stars around it and releases a ray burst like this, then it is called as a quasar. Groups of galaxies are called as galaxy cluster, and groups of galaxy cluster are called as superclusters. Now let's come to smaller celestial bodies. Comets. These comets are small rocks covered with ice due to vacuum temperature of space about minus 137 degrees centigrade. But when they enter our solar system, our sun burns the ice around them and it is visible like this in the night sky. Asteroids. They are small rocks covered with metals and minerals, and most of the asteroids present in our solar system are present in between Mars and Jupiter's asteroid belt. Meteors. They are smaller than asteroids, but they form when an asteroid turns into small pieces and they enter our atmosphere. Due to atmospheric pressure and temperature, they will burn and break into pieces, and those burning pieces are called as meteorites. Till now, we explored just 5% of our universe, normal matter, and the remaining 95% goes to dark energy and dark matter. Scientists assume that this dark matter and dark energy are one of the cause of gravity existing in our universe, and this is the only thing that scientists ever observed about dark energy and dark matter. Now, let us come to the hypothetical part of this video, white holes. These white holes are completely opposite to the black hole in our universe. Black hole absorbs everything into it, and white holes releases everything out of it. Scientists assume that these white holes may present in the backside of the black hole, like shown in this figure. Quasar star. This is a hypothetical star because this star contains a black hole inside its core due to very high pressure inside it. This quasar star is biggest star ever observed in our universe till now. After some years, this star will collapse into itself and become a fully fledged black hole. Multiverse. You guys are quite familiar with this word because everybody knows that multiverse is nothing but multiple universes. But unfortunately, we can't see the edge of our own universe because universe itself is expanding millions of times faster than light. Due to this behavior of our universe, we are unable to prove that multiverse theory is right. I hope you learned something new in this video, guys. That's it for this video, and I will see you next time.